All right, so today, if you look at the heading, we're going to be finding the center and radius by completing the square. But before you can do that, I need to teach you how to complete the square. So going back to quadratic equations, okay, you can, if you have, again, your quadratic, I'm going to add the term real, though, to my title. The number of possible real roots, real zeros, real solutions, again, they all mean the same thing. We're looking at how many times the parabola crosses the x-axis. Okay? Next year in Algebra 2 Trig, you will learn about imaginary solutions or imaginary roots. But right now at this point, you've only learned about real solutions. So you can have the parabola cross twice, as you see in the first example, or the parabola touch once. Now, you may not quite understand why they call this a double root, because when you solve a quadratic and you factor, you have two factors. So say this was that maybe it looks like it's over 2. So the factors might have been x minus 2 times x minus 2, and each of these factors, when you solve, you've got the solutions 2 and 2. Well, we don't give our answers as 2 and 2. We just simply say the answer's x equals 2, and that's where it crosses. But just realize it's because of a double root. So take the time, okay? These are methods you have learned, okay, in solving or finding the solutions of a quadratic equation. So just scroll through and look at the columns. Again, this is just a review of what you've already done. All right, so in the first column, okay, when given a quadratic equation to solve, if you can factor, you should factor, okay? There may be questions, though, where it specifies a method. Solve this equation by factoring, solve this equation by graphing, solve it by quadratic formula, so on and so forth. So if you can factor, factor. Okay, remember the factors of 8 that add to 9. So 8 times 1 is 8, 8 plus 1 is 9, and then you get your solutions. Now up here when it says use when c is 0, that's referring to something such as x squared plus, say, 5x equals 0. You have no c term, because remember, in a quadratic equation, it's ax squared plus bx plus c. The a is the number before the x squared, so if there is no number, it's a 1. Okay? B is the number before the x, so in this case, we have b is 9, a is 1, and then c, the last number that's not attached to a variable, so your constant, is 8. Okay? Now, if you have your b value equal to 0, so there's no x term here, it's really easy. You can still factor x plus 7 times x minus 7, but it's easier to use the square root method. Okay? When you have approximated solutions, so from this answer here in the quadratic formula, you could get the equivalent decimals. Okay? But when you solve by graphing, again, you're looking at the x-intercepts. You don't necessarily need to use it only when you have approximate solutions. You can use it all the time to check. But it is good to see when you do have the approximation, okay, what's this equivalent to? And don't forget, you can use the trace button on your calculator, but also you can calculate your roots using the calculator as well. Okay? But if you have a highlighter, it's just important to note that whatever method you use, you should get the same answer. Okay? So at the bottom, again, we looked at some questions that involved perfect square trinomials last class in your class work. Okay, and then we looked at also some on the homework. A perfect square trinomial, again, you're given 2, is a trinomial that factors into two binomials that are the same. So if I were to factor x squared plus 6x plus 9, and x squared minus 16x plus 64, how do they factor? Can someone tell me the factors of x squared plus 6x plus 9? Damien?
3 and 3.
Not just 3 and 3. I should hear binomials. So x, x.
Well, plus positive 3 for both of them.
Plus 3 plus 3. Yep. So the factors are x plus 3 squared. So when we go to factor today, I'm going to be going right from here to there. Okay, but I want to show you for both, again, when you factor, your factors should be identical. So x times x is x squared from one on the right. Factors of a positive 64 that combine to negative 16 are negative 8 and negative 8, which is equivalent to x minus 8 squared. Now in every perfect square trinomial, and I'm going to give you a couple minutes to talk about this with somebody around you, okay, close by, there's a relationship between your b value and c value in every perfect square trinomial. Okay, so down here we're going to fill this in. It says in every perfect square trinomial the c value is equivalent to, and I want you to see if you can fill in that blank. So take a moment, discuss the relationship between your b value and c value. Yes. Yep. So in both, okay, if you take a look at the c value, in this case c is 9, 9 is equivalent to half of 6 squared. Half of 6 is 3. And note, your 3 is what you're putting into each of your binomials that are the same. So 9 is equivalent to half of 6 squared, and 3 squared is 9. Over here, the same applies. Our c is 64, and 64 is half of your negative 16, which gives us the negative 8 squared. So she is right. C is equivalent to half of the b squared. So on the back side, given the b value, I want you to tell me what c is going to be. So you have 3 examples. Find the value of c that will make each trinomial a perfect square trinomial. Again, so we know that c is equivalent to half of b squared. So you can do that every time. So in the first one, half of 4, or 4 over 2, squared. 2 squared is 4, so my c is 4. Another way you can do it, and this is the way that I do it myself, I don't memorize that. It's half of b squared. I start to factor. Okay, I know these factors have to be the same, and the sign in the middle is going to be the sign in my binomials. And I know that these two numbers add to 8, and they have to be the same. So it must be 4 and 4. Negative 4 plus negative 4 is 8. And then I go and I multiply, again, in FOIL. The L stands for your last product. Negative 4 times negative 4 is 16. But you can still do negative 8 over 2, which is negative 4 squared, gives you 16. I start to look at the factors because we're going to need the factors further down the page when we go to solve by completing the square. So the last one, though, when I go to set this up, minus, I'm looking to find half of 3, or two numbers that actually add to themselves to get 3. Damien?
3 over 2 or 1.5?
Yes, 3 over 2 or 1.5. I would like you to leave it in the form of a fraction, so improper fraction in this case. So leave it as the 3 halves. It's always going to be, if you have a number in the middle, so in the b spot of the trinomial, if it's not divisible by 2, these two numbers are going to be something over 2. So then negative 3 halves times negative 3 halves, again, if you multiply your last two terms, you get 9 fourths. So again, I'd rather see the improper fraction than the decimal. You could also, again, take half of b squared, okay? And that would work as well. So again, something new this year, solving a quadratic by completing the square. So take a minute to read through the steps. I'm not going to read them aloud to you, but I will as we go through the 2 questions on the bottom. I'll highlight the steps. All right, if we go back up again to the first step, which says to divide out, and again, I've seen you guys do that a lot this year, and we'll discuss that more. But actually, we'll right now take a look at part B. Every term in B has a common factor of what? 4. So what I've seen you guys do in the past is divide the whole thing by 4 and then give me the quotient or the answer. I don't want to see that because later on, say in Algebra 2 next year, the GCF is not always numerical. Could be a variable, could even be combined, say, such as 4x. That x part of that GCF is going to give you a root or solution. If you just divide it out, you'll forget that root. So I want to see the GCF out front. So x squared plus 4x minus 1 equals 0. So that's step number 1. So we can actually, divide out means the same thing, but if you want to change it to factor, you can do that as well. Number 2, move the C term to one side of the equation and add your 2 boxes. How do I move, in this case, the negative 24 over to the other side? What's that? I add it, okay? I'm going to, again, in solving equations this year, I've been, writing the next line without showing the inverse operations, and that's still okay. So I'm going to move the C term over, becomes positive 24, and then again, this part of the original trinomial is the start of a perfect squared trinomial. So bring down the x squared minus 2x, and then I'm going to add a box for a placeholder. Okay, this is also called the box method. Some teachers call it the box method. Again, all the box is your placeholder. So from parts A, B, and C at the top, this is the box. But why do you every time add it? Why is it never subtraction? Why do you always add the box to both sides? Cody?
If it's a square binomial, so like x minus 2 times x minus 2, the negative 2 times negative 2 is positive 4. So if it's a square, then the C will never be negative.
Yeah. If you're looking at the square of two numbers that are always the same, whether they're positive or negative, negative times negative is positive. Positive times positive is positive. So that's why in every case, again, as he was saying, it doesn't matter if the B term was positive or negative. When you go to square this last term, you're always going to end up with a positive answer. So we add the boxes. That's step number 2. And then what goes in the box, again, don't forget to add it to both sides. It's an equation. You need to keep it balanced. Whatever you do to one side, you must do to the other. Now we're going to put in each box half of the B squared. So half of a negative 2 is a negative 1. Negative 1 squared is 1. Step number 4 is factor the trinomial. Again, I would like to go right to this point here. How does that factor? X squared minus 2x plus 1. That's the square of what binomial? Tanner? X minus 1 squared equals 25. Next step, we take the square root of both sides because that's the inverse of squaring. So when I take the square root to the left, it gets rid of the square. I'm left with the binomial x minus 1. And then equals the square root of 25, which is positive or negative 5. Don't forget your plus or minus. Finish by adding the 1. The 1's cancel out on the left, and x equals 1 plus or minus 5. We put the 1 up front. Again, you can have positive or negative 5 plus 1. It looks better in this format, okay, but it's also in the same format as the quadratic formula. X equals negative b plus or minus square root. All right, and you keep going if you want. Now, so here, again, this is going to give me 2 solutions, 1 plus 5 and 1 minus 5. So one answer is 6, the other one is negative 4. So as a solution set, we've got negative 4, 6. All right, to finish up with the one on the right, again, I want to see the GCF out front and not the division by 4 and therefore gone. I want to see that factor. So now I'm just looking here. So I'm going to take that trinomial and turn it into a perfect square trinomial. So I have to move the 1 over. So this is going to be x squared plus 4x plus the box, so our placeholder, equals 1 plus the box. Again, you can memorize half of b squared, but what I also do is I look at, okay, what's the factor I'm going to use? Well, if it's the same number that adds to itself to get 4, a positive 4, it must be a positive 2. And then 2 squared is 4. That's how I do it, okay? And then if I add the 4 on the left, I have to add the 4 on the right, and we get 5. So now to solve the equation x squared, or x plus 2 squared equals 5, I take the square root to get rid of the square. So I've got x plus 2, take the square root of the right, is plus or minus radical 5. Finish by subtracting 2, and we get x equal to, again, writing the negative 2 first, so it's in the same format as the quadratic formula, negative 2 plus or minus radical 5. We're going to complete the square to find the center and radius of a circle. At the top, note I have the 2 equations. One is with the center at the origin. The other is with the center not at the origin. Okay? We can use, I'm just reading the paragraph below, completing the square to change a circle. So here's the general form, is what you see down below. We can convert it to look like this, which is the center radius form, and once it's there, we can then easily identify the center and radius. So what's different here is that if you look down below, we have some x terms and we have some y terms. So what we're going to do is we're going to complete the square for both trinomials. So what we're going to add this time is going to be 2 boxes to each side rather than the 1, because we have an expression with x's and we have the expression with y's. So therefore, I have putting it, again, in order with the x's all together from highest to lowest, or descending order. I've got x squared plus 8x, and then, again, that's part of the 1 perfect square trinomial. And then I'm going to put the y terms in order from highest to lowest. Add in the box to complete that perfect square trinomial. And then I'm going to write again, I'm going to skip showing the addition of 75 and just put that on the other side. But remember, you have to add your 2 boxes because you added 2 boxes to the left. All right, so now, again, what goes in the box is half of b squared. So we write it in order. The x terms first, the y terms second, highest to lowest, and then what goes in the box is half of b. So half of 8, positive 8 is 4. 4 squared is 16. And if I add that on the left, I have to add it to the right. Now here, again, half of negative 6 is a negative 3. Negative 3 squared is 9. Now I'm going to go and factor these 2 trinomials, again, that are now perfect squares. So this one factors x plus 4 squared. The second one factors y minus 3 squared. It's now in center radius form. If you compare that to the top, here's your left side of the equation of a circle. Equals, what's the sum of 75, 16, and 9? 100. So there's your equation of a circle in center radius form. So our center, again looking here, we have a center of negative 4, 3. Again, this is equal to r squared, so taking the square root, we've got the solutions of 10, negative 10. Rejecting the negative, the radius is 10. So the last one, so go ahead on your paper, put it in standard form, add in your boxes, and then we'll take a look up here to finish. All right, now to complete our perfect square trinomials, the C value in each case, half of 10 is 5 or positive 10, so positive 5 squared is 25. Half of a negative 4 is negative 2. Negative 2 squared is 4. So I've now filled in all of the placeholders or boxes. So now I'm going to go and factor each trinomial. This is x plus 5 squared, as 5 plus 5 is 10. 5 squared is 25. The next one is going to be y minus 2. Negative 2 plus negative 2 is negative 4. Negative 2 squared is 4. And then equals, what's the sum of 7, 25, and 4?
36.
Which is another perfect square. You don't always get a perfect square. So our center, again, looking here, our center is negative 5, 2. Again, radius is going to be 6.